In today's video, we're going to be describing horizontal motion. But before we get started, we need to define speed and velocity because they are a little different. Speed is simply the rate of motion. It's a scalar quantity, which means it has magnitude but not direction. While velocity is the rate of motion in a certain direction. Where x represents the change in displacement. Okay, it can have two directions. It can be positive or negative. And I like to use positive if it's moving towards the east and negative if it's moving west. So velocity is a vector quantity, not scalar. Let's attempt to draw some examples of some graphs of different types of horizontal motion. First of all, let's draw something like this. Okay, so I can say that we have a steady speed here. Okay, so a constant speed. All right. The next portion here, this will be at rest. It's not moving, it's stationary. The third segment is the motion is returning to the point of zero. So it's returning. The slope of the line tells you the velocity. If I were to draw another line like this one, I can say that this line is traveling faster than the other one. Let's be faster because it has more slope. If I draw a curved line, okay, that shows that it's getting faster, okay? Which means it's accelerating. If I can draw a line kind of the opposite direction, something like this, then that will be slowing down or decelerating. So to recap, we could say that a straight line with slope represents a constant velocity. The slope of this line is the velocity of the motion. If the slope is positive, the object is moving away from the source. A negative slope means it's returning towards the source. A straight line with zero slope represents the object is at rest. A curved line represents the object is accelerating or decelerating. If it curves upward, it's accelerating, and if it curves downward, it shows deceleration. This next graph is a velocity versus time graph. Let's try to draw some lines to represent different types of motion here. If I draw a line such as this, that means it's accelerating slowly. If I were to add this, that means it's accelerating more quickly. If I were to draw something like this, then it means it's traveling at a steady rate. All right, let's draw something that shows that it's slowing down. So if I were to come like this, it's slowing down. And if I continue here, it stopped. Here it is speeding up in the opposite direction. And it's going at a steady speed in the opposite direction. So it's speeding up slowly. And now it's speeding up more quickly or accelerating faster. It's traveling at a steady speed or steady rate. It's slowing down. And it looks like it's slowing down very rapidly. Here it is stopped. All right, now it's speeding up in the opposite direction. And here is traveling at a constant speed. If I want to know the displacement from this point to this point, if I could find the area here, this triangle would be 1/2 base times height. Okay, the area here we equal 1/2 of the base times the height. And that would give you the displacement, or how far it traveled in that direction. And you could continue doing this for any portion along this graph. All right, so for some useful formulas here, the symbol for displacement, we're going to let it be an x. Velocity, I like to put VI, or you can use VO, whichever you prefer. Final velocity. Acceleration. I'll use a lowercase t. So the equations that we'll be using most of all will be x is equal to the initial velocity times time plus 1/2 of the acceleration time squared. The final velocity is equal to the initial velocity plus acceleration times time. Or I can say the final velocity squared is equal to the initial velocity squared plus 2ax. All right, these formulas will get you by pretty much for any types of horizontal motion, where the displacement x is equal to the initial velocity times time plus 1/2 the acceleration time squared. This is for the period of time in which it is changing velocity, when it's accelerating or decelerating. The second formula is basically when you have velocity, time, and acceleration. The third one is when you have velocity, acceleration, and displacement. Here's a sample problem that helps you to see the difference between speed and velocity. So a runner runs 1,000 meters and turns around and runs 500 meters back. So here's my little guy here, okay? So he's going to run 1,000 meters, then turn around and run 500 back. So if this were 1,000 meters total, so this will be 500 meters here. Speed is the total distance divided by the total time. So therefore, his total distance will be 1,000 plus 500 divided by 4 minutes. So that would be 4 times 60, which is 240, right? So that's 1,500 divided by 240. So that gives me approximately 6.3 meters per second. Okay, that would be his speed. Velocity, on the other hand, is the change in displacement over the change in time. Okay, so this velocity is going to equal, all right, so how far did he run? Well, he ran 1,000 to the positive direction, and he ran 500 in the negative direction. And the total time was, again, 240 seconds. So that's going to equal a displacement of 500 meters and a time of 240 seconds. So his velocity is going to be approximately 2 meters per second. So you can see the difference then between speed and velocity. Since speed is scalar and velocity is more vector-based. Okay, this next problem. A man runs 4.5 meters per second for 15 minutes. When he approaches a hill, he slows at a constant rate of 0.05 meters per second squared for 90 seconds and comes to a stop. How far did he run? Well, I like to treat this as two separate problems. Okay, this part I will do, calculate this displacement, and then we'll do the second part and add it together. So I'm going to call this the A part here. I'm going to say that x equals the initial velocity times time plus 1/2 of the acceleration times time squared. So this is going to be 4.5 times 15 minutes. So it's 15 times 60 plus 1/2. He's not accelerating. So I'm just going to ignore that part. So this will be 4.5 times 900. So that will be 50 meters. That's how far he ran during the first part. Okay. Now on the second part of this problem, we'll use the same formula. So x is equal to his initial velocity. He was still going 4.5 when he approaches the hill. The time going up the hill was 90 seconds. Now, he's going to be decelerating, so I have to put a negative acceleration, 0.05, and 90 seconds squared. So this is going to be 405 minus 202.5. So that gives me 202.5 meters. All right, so if I add these two together, 4050 plus 202.5, both of these are meters, it would give me 4252.5 meters. And we want to go like 2 sig figs or something like that, so we would say approximately 4,300 meters. So a bicycle rider starting from rest coasts down the hill with a constant acceleration of 2 meters per second squared. At the bottom of the hill, he'll be traveling 18 meters per second. If we were to maintain this velocity for 1 minute, how far would he travel from the top of the hill? Again, this is a two-part problem. So we'll do the part going down the hill first. We'll take care of this first. And then we'll do the second part. This will be the A part. We have two velocities. Since he starts from rest, we know his initial velocity is 0. We know his final velocity is 18 meters per second. We know acceleration. Let's use the formula. Velocity squared equals the initial velocity squared plus 2ax. So his final velocity is 18. We're going to square that. Equals 0 squared plus 2 times the acceleration times x. We're solving for his displacement. So that's 18 squared equals 4x. 18 squared is 324 equals 4x. Divide both sides by 4, so x equals 81 meters while he was going down the hill. All right, for the second part, he's going to be continuing at 18 meters per second for 1 minute. So we're looking for that displacement also. So again, we're going to use x equals the initial velocity times time. And since he's going at a constant speed, we can ignore that portion. So it's 18 meters per second times 60 seconds. So that would give me 1080 meters. So my total distance traveled will be 1080 plus 81. That gives me 1161 meters. A woman is traveling in a car at a speed of 23 meters per second. She sees a deer in the road 210 meters ahead. If she stops right before hitting the deer, what is her acceleration? We're going to be using the formula final velocity squared equals the initial velocity squared plus 2ax. All right, so the final velocity is going to be 0 squared. The initial velocity is 23 squared plus 2 times the acceleration times x, which is 210. Okay, so let's take this to the other side. So 2 times 210 is 420, and it's going to be negative. So that's going to equal to 23 squared. And I need to put my a right there. So divide both sides. So it would be 23 squared divided by negative 420. That's going to be negative 1.26 meters per second squared. A child is in a cart and accelerates from rest to 5 meters per second in 4.5 seconds. Then continues to speed for another 4.5 seconds. What's the total distance traveled? Again, this is a two-part problem. So let's find the distance that he travels while accelerating, and then we'll find the distance going at a constant speed. First, I need to find the acceleration. The final velocity is equal to the initial velocity plus acceleration times time. So the final velocity is 5. The initial velocity was 0 since it started at rest, times acceleration times the time, which is 4.5. So we say that 5 equals 4.5a. So acceleration dividing both sides by 4.5 is 1.11 repeating. That'll be meters per second squared. Now let's find the distance while accelerating. The distance is equal to the initial velocity times time plus 1/2 of the acceleration times time squared. The initial velocity was 0 times time, so I'm going to ignore that, plus 1/2 the acceleration, which is 1.11 repeating, times 4.5 squared. This gives me a displacement of 11.25 meters. Okay, now we're going to be going at the second part, which is going at a constant speed. So this is going to be the initial velocity times time and we're going to ignore this part. So he's going to be going at 5 meters per second for an additional 4.5. This gives me 22.5 meters. All right, so if we were to add 11.25 meters with 22.5 meters, if we round this off, they're 34 meters. Either one of these should be good. Okay, a biker is traveling at a rate of 2 meters per second. If the biker accelerates at a rate of 0.45 meters per second square, how long will it take him to travel 600 meters? Okay, so we're going to say that x is equal to the initial velocity time plus 1/2 of the acceleration times time squared. All right, so he's going to be traveling 600. The initial velocity is 2 times t plus 1/2 of the acceleration, which is 0.45 times t squared. So we'll say 600 equals 2t plus okay, let's start over. A biker is traveling at a rate of 2 meters per second. If the biker accelerates at a rate of 0.45 meters per second square, how long will it take to travel 600 meters? All right, let's say x equals the initial velocity times time plus 1/2 of the acceleration times time squared. So we're going to put 600. The initial velocity is 2 times t plus 1/2 of 0.45 times t squared. 600 equals 2t plus 0.225 t squared. Let's place this into a quadratic format. I'm going to take the 600 to the other side and rearrange the terms. So I'm going to have 0.225 t squared plus 2t minus 600 equals 0. This looks more familiar for those accustomed to doing quadratics. So we have a is equal to 0.225, b is equal to 2, c is equal to negative 600. And we'll plug it into the quadratic, which is negative b plus or minus the square root of b squared minus 4ac, all this over 2a. All right, so let's solve for our two roots here. So I have negative 2. I'm going to do the plus first, plus the square root of, okay, so b squared, 2 squared, minus 4 times a times c, all this over 2 times 0.225. All right, when I solve this, I'm going to get 47.4 seconds. Okay, let's solve it for the other root. So it'll be minus 2 minus the square root of 2 squared minus 4 times 0.225 times negative 600 all this divided by 2 times 0.225. When I solve this, I get negative 56.3 seconds. I cannot have negative time, so my time would have to be 47.4 seconds. If you get this one right, very good. Thank you for watching. Please like and subscribe, and I'll be back with you soon for another video. Thank you very much.